Okay, so we are going to be talking about sinusoidal functions. Now, a sine function, I actually just want you to see what even one looks like. I don't know why this wants to open two calculators on me sometimes. Okay, but the way that you do a sine function is, first of all, you have to decide what mode you're in. Okay, now if you hit the mode button, which is right beside the second button, we're going to be going through these two, radian and degrees. In fact, we're going to spend most of our time in radians. So brand new, has you never learn it till 30-1 or 30-2. You don't learn about radians. So if I was in radians, oops, I did not do that. You have to hit enter, and it will blink on radians. Yeah, let's try it. Okay, so anyway, let's do a graph. My x-min, I'm going to go from 0 to 2 pi. So you put 2 and the pi sign. And scale, let's use pi over 6. You go second pi divided by 6. Okay? My y-min, put in -2. My y-max, we'll put in 2. Okay? Then we're going to go to y equals, and all you're going to do is put sine x. And then we'll graph that. Now, that's called a sine curve. And we're going to really learn about this curve a lot and how to mess with the curve. 2. So I can make them higher and lower. Okay, so this from here to here, that's called my amplitude. Okay, that's how tall the wave is from the, what I call the midline, the middle. Do you see how that's the middle of the graph? So if I wanted to make that bigger, okay, I would go 2 sine x. And you see how my amplitude changes. Okay? So we're going to learn that this number in the front always affects the amplitude. Now, what if I want to squish this thing in? Well, then I'm going to mess with this. Okay, so then we start to see, oh, what that thing in front of the x does. Now, what if I want to move this, the entire graph, up 1? Well, I would take this graph and move it up 1. Okay, see what I did there? Do you see where the midline is? See how it moved up 1? Okay, now I can actually take this graph and move it to the right. So then I would go, and I just hit my insert button. I don't know if I'm in insert. Okay, so then I can do this. Okay. Oops, I need to put a bracket in here. Okay, so I've moved the graph to the right. So what I've just done in a nutshell is the entire unit. Okay, we got to know. I'm going to ask you, guys, what would change this thing so it would move it up? What would squish this thing? What would make it bigger? Which one of them? Okay, what if I want to move it right or left? What would I do? Okay, so again, if you don't know the rules, right, there's no way you will pass this exam. Okay, and if you do know the rules and you put everything into place, you will get 100. Okay, does everybody believe me now when I say you can get 100? Like, am I just like, oh yeah, he talks all this 100 crap. We got like a 65 average. Half of us are failing. Where's this 100 stuff? Okay, so we're about trying to master it. Okay, that's all we're doing. And some of you can start to see right now, you know, how to be able to take this and manipulate and everything. But we're going to start. So I've kind of showed you the ending. Okay, that's how it's going to end. But we got to learn a few things before we do that. Now, the first thing you have to know is you have to know what a sinusoidal function is. Now, the biggest mistake students make is they think that that's about a sine graph. And it's not true. Okay? A sinusoidal function is a cos graph, could be a tan graph. Okay? Now, we're not going to learn tan graphs, but we're going to learn sine and cos graphs, and you're going to see, but 90% of it is the sine graph. But a sinusoidal function is any periodic function whose graph has the same shape as y equals sine x, okay, or cos x. Now, because we just need to get you to learn about all the different pieces of manipulating, we're going to work with sine, because if I tell you all that, you could just transfer it to cos. The rules don't change. But sinusoidal function is basically any periodic function. Okay? And basically, it repeats. Oops. It repeats. Now, the pattern must repeat. Okay? So like our sine graph goes like this. Oops. Gotta keep going the same, right? Means no matter how long I go, it will go in both directions. So we're going to be looking at this. Y equals a sine b x minus c plus d. Or y equals a cos b x minus c plus d. Are these Russian? Regression. We will be doing regression. I was like, Russian? Now, what do you think A stands for? Can you remember?
The indicator of negative or positive.
No, look on my, remember I did it on the calculator minutes ago. That's how high and how low it's going to go. It's called my amplitude. Okay, B affects the period. When I mess with B, I squished it in or I made it, it's like you pull it or squish it. That's what B is going to do. C moves the entire graph left or right. D moves the entire graph up and down. Okay? You need to know that. You need to know, you got to be able to look at a graph and be able to make this. Okay? So you're just going to look at a graph and you're going to be able to make this entire formula. That's where you got to get. So, many could argue this is a lot easier than the last one. But if you don't practice this one, you will never get it. Okay? You will keep making, obviously, the same mistakes. Now, I want to just talk about, so we're not going to do this. I want to just talk about degrees and radians right now, because that's, we're going to start kind of with baby steps here. But if this was 0 degrees here, now, if I started here and went to here, how far have I gone? 90 degrees. Now, if I kept going, so now I'm doing this, what would that be? 180 degrees. This is 270 degrees, and this is 360 degrees. Okay, it's key that you know those. And I'm using the unit, the way the unit circle works. It starts at 0, starts at the x, and we go counterclockwise. Now here's the new ones for you. Okay, this is actually 0 radians as well at this point. Now, or 0. Now if you just see 0 all by itself, it means radians. If you see a little degree sign, it means degrees. Now if you mix these two up, it's not going to hurt you. It's the other ones that will. So when you're in radians, you don't call that 90 degrees, you call that pi over 2. Okay, so let's, in red, that would be pi over 2. So I kind of want you to know that pi over 2 is the same thing as 90. Do you have to memorize that? No. Just helps get your bearings, right? I don't want you just getting answers. I want you to go, yeah, that seems right. Okay? Now, to go halfway around a circle is called pi radians. Very timely that it's pi day, that we're learning about pi. And if you're going to go 3/4 of the way around, aka 270 degrees, you're going to go 3 pi over 2 radians. And guess how far you're going if you go all the way around? 2 pi. Now, all of these can be 2 pi or 2 pi radians. Now, the ironic thing about learning radians is that's what the entire mathematical community uses. Like if you're working for NASA, you're in radians. You're not in degree mode. So students learn degree all the way to grade 11 and grade 11. And then grade 12, you're actually taught what is the most commonly used, which is radians. Because they're more difficult, but they're more specific. So radians is perfect. If you did, like, you know, this distance here, pi, like this number, you know, it's 3.141592653.5, right? Just keeps going on forever. It is obviously a very, very, very specific unit. When degrees, right? You got 181 degrees, 180.26 degrees, right? How many degrees do we really go? So pi is a very specific number. And the once you understand what a radian is, it's actually easier to use and less math to do, less work, okay? But what you will find, and what I found when I was going through it, is you want to hold on to degrees. You want to keep translating to degrees, right? Just like I know some French teachers, they will not teach translation in their class. They want you to learn French as it is French, right? Because when you do translation all the time, it actually hurts the learning, right? You got to get them inundated with the French. The French, keep speaking French to them. And so we got to get off the degrees. We got to wean ourselves off degrees, and we're going to be talking in radians. Now, it's not too heavy. Like in 30-1, it's heavy. Okay, you do everything's in radians. You do tons of math with it. We don't have to. Okay, we just have to know that when you're doing your regression, you're in radian mode. And because radian is the accepted, it will not be written. When you're saying the angle's 2 pi, you're not asking if that's degrees or if that's radians. Okay? Or say they just give you 2.68. If it says 2.68, that is radians. Why? Because there's nothing there. If I wanted it in degrees, I'll put degrees. If I want it in radians, I'll put nothing. Okay? So you can have 2.8 radians, or sorry, 2.6 or 2. These mean the same thing. Right? Just like square root, just like that 10 in the log. It's not going to be written there a lot. Radians is not going to be written there a lot. You just have to know. So what is a radian? Okay, well, Again, I'm going to keep this as simple as possible. As simple as pi, hopefully. Now, a radian actually is, for any circle, it is like a piece of pizza or a piece of pie, that the radius and that arc are all the same length. Okay, now in a half of a pizza, just by looking at the shape, how many think fit in a half? So roughly 3? Does that make sense? Well, guess how much it is? It's 3.14 of them. That's why it's called pi radians. Do you understand why there's 3.14 of them in there? Okay? That's how many radians fit in there. And this angle is roughly 58 degrees. Okay? So 3.14 radian, pi radian. And do you see how about 6.28 radians would fit in the entire thing, which is 2 pi, right? So that's where, that's one of the reasons why pi radians fits here. So just so you know, this is like 360 degrees, and this is like 180 degrees. So again, what is a radian? It's a piece of pizza where the radius and this is called the arc, right? Because it's curved. They're all equal. The radius equals the arc length. Okay, and that's how it came to be. Now, again, I don't want to beat this to death, right? I want you to kind of understand what it looks like. When it says, you know, 4 radians, right? I do want you to be kind of thinking, you know, well, that it's like 1, 2, 3, 4. Yeah, it's about that angle, right? That would be 4 radians. 3 radians would be around 180 degrees, right? Because there's only 6, right? It's like, you've all played Trivial Pursuit, right? That little guy, you know, that you put your little pies in? No, you never played that? Okay, it's like that. There's 6 of them. Okay, I think it's 5 actually, so forget I said that. Okay, it might be 6 though, I should check that out. So, I'm not going to see all this writing, not going to go through it. That's what a radian is. A radian's a piece of pizza. And there's approximately 6 of them in every circle. But 6.28 to be specific, and 3.1415926 for half. I just do it to 10. Yeah. Yes. No. No, there was a Simpsons one time. I don't know if you guys watch The Simpsons. But Lisa wanted to get to school fast because she had a math quiz. And if she got 100, she was going to get the teacher was going to give her a protractor. And Homer thought that was ridiculous because they didn't even have a farm. Okay, that one might hit home later. I know you'll be using that around the old supper table. Okay, so key ideas. I need everybody back. I know that was overly funny, but I need you all back. Okay, a radian measure, it's the alternate way, it's another way to express the size of an angle. Use radians allows you to express the measure of an angle as a real number without units. Now sometimes you will see it with RAD beside it, but if there's nothing, it means radians. So if I wrote down 360, that doesn't mean, I know it looks like degrees, but it's not because it doesn't have a degrees. That would be 360 pieces of pizza, okay? So without the, so you know how your teacher's always like, put the degrees on there, put the degree, and you're like, oh, I know it. I know it's degrees, right? Well, then if you're not in that habit and you're not putting degrees on right now, I'd be like, do you mean radians? Like, what do you mean? You didn't put anything. So now nothing means something. I know that's deep, but Okay? So 2 pi 360, pi 180, 180 degrees. Know those, okay? And you know what? Pi over 2. Does that make sense? That'd be 90 now. Okay? And 3 pi over 2, that's 1.5 pi. Right? That's what that means. So now, and then, of course, 2 pi is 180, okay? Or 360. Okay, so I want you to know those so you have your bearings. I'm going to teach you today how to convert, right? Because when we're talking about radians this whole time, I can't have you, like, what is that? Like, okay, like I get it, we're going to do it in radians, but I don't even know what that means. I don't even know what that looks like. That's not effective learning, obviously. Okay, so here's all the things. 1 radian is equivalent to 60 degrees. And it kind of makes sense because, right, we got 60, 120, 180. So 3 of them kind of fit in there. Pi is equivalent to 180, and 2 pi is equivalent to 360. Okay, again, here we have what a radian looks like, and it's 57.3 degrees. Now, I just want to, because I even have something like, you will see something like this in the diploma. Okay? So, what angle, let's put it this way, sorry. Joe walks in at 11 o'clock. He leaves at 11:45. What angle did the minute hand go? Okay, so, oops, I don't want to draw that. Let's just draw. So we've got 11 o'clock would look like this, correct? Now, this hand is going to go clockwise, hence the name. How many degrees do you think it would have go? It would go 90, 180, 270, right? Does that make sense? Okay, so the clock is often used on the diploma, right? He leaves at 11:30. What angle did the minute hand go? Okay, 180, right? They're not going to be picking, oh, he left at 11:27. Okay, they're not going to do that. Okay, they're going to pick your 30s, your 15s, or your 45s. But they might ask that in radians. Okay, so this, what was 90 degrees, do you remember?
Pi.
No, pi over 2, 180,
3 pi, like,
pi,
oh,
and,
3.
okay. And then if he was there for an hour, it was either be 360 or 2 pi. Okay? Now, here's the kind of thing we're going to be working on today, and it's like, let's change from degrees to radians. Now, you already know the answer to this one because we've done it a couple times, but I'm going to show you how this works. Okay? So, when you're converting from degrees to radians, so from degrees to radians, we multiply by pi over 180. Now, if you multiply anything by 1, does it change the number? Is pi over 180 1? How many degrees is pi? How many degrees is pi? So is this not the same thing as saying 180 divided by 180? So am I multiplying by 1? Yes, pi and 180 are the same. Right? You guys like agreed with me here. You're like, yeah, okay, I got it. Okay? Then I go to here and you're like, what? Those are the same? Okay? They're the same. When you take the same divided by the same, that equals 1. Cow divided by cow, 1. Okay? It is. Now, all you do is you multiply this by pi over 180. Now, here's the way that you got to do this. You go 90 times pi would be 90 pi over 180. Now, leave the pi where it is. And again, I'm going to teach you how to use your calculator to do these. So you get out of here, and all you go is 90 divided by 180. And then you're going to hit math, enter, enter. And that will reduce your fraction for you, which is 1 pi over 2. Do you see that? So did I do anything with the pi? No. All I do is I put this into my calc. Then we're going to go math, enter, enter. Which is the same thing as pi over 2. Right? And did I say that 90 is pi over 2? Go look on your chart, right? Now 120 degrees isn't on those ones I gave you. So we're really going to need this. Okay? So from degrees to radians, I multiply by... Hello? This thing on? Huh? What do I multiply? The same? Pi over 180. Because are pi and 180 the same thing? Yes. So I can multiply anything by 1. I don't change it. If I take something and multiply by 5, does it change it? If I multiply by 1, it doesn't change it. So you always got to satisfy two masters here. Number 1, I can't change it. But number 2, I've got to get it in the way that I'm asked. So I've got to get this thing in radians, and I can't change it. Okay? Now, you put just the 120 divided by 180 in your calculator. Math, enter, enter. What did you get? So that's 2. And now, did the pi go anywhere? Pi doesn't go anywhere. 2 pi over 3. For you guys, most times there's going to be a pi in the answer because it's radians. Okay? Now let's do 240. 240 we're going to multiply by what? Pi over 180. That's not on your formula sheet. You have to know that. I got to multiply by pi over 180. Okay, so you're going to go 240 divided by 180, math, enter, enter, and what do you get? 4 pi over 3. Or 4/3 pi. It is the same thing, but that's how it's said, 4 pi over 3. Okay, now this one says estimate. Okay, but we don't have to on that one. That one works out nice. Okay, let's do the next one. 450. Multiply that by pi over 180. 5 pi over 2. Okay, now, is this hard? No. Is it impossible if you weren't here today? Probably. I'm not going to have many students that will be able to do this tomorrow if they weren't here today, or they didn't watch the video. And that is another absolute strength of this class, is the attendance. Okay? The attendance is awesome in this class. That's the only reason we can be getting these marks, because if you're not here, it is like a crap load of work trying to get you caught up all the time. So, from degrees to radians, we will multiply by pi over 180. Can you start to picture what your study sheet's going to look like? Okay, get that on there, right? If tomorrow you don't know this, you didn't do a study sheet, okay, and then hey, you're coming in and you're going to rewrite that quiz, or you're not going to come in and rewrite that quiz, and you're not going to get it on the unit exam either. So it just spirals, right? So why don't we start strong, get that study sheet done, so you can be in every test with it done. Now here's the other ones. If we want to go radians to degrees, we have to multiply by 180 over pi. Now the thing that comes up, it's, ah, crap, I hope I don't mix those up, because they kind of look alike. They're just flipped, right? Now, do you see how they're both multiplying by 1? Right? So that hasn't changed. I mean, 180, if you thought pi over 180 was 1 and I flipped it and you're like, no, I don't think that's 1 anymore, okay, we'd have to have a little chat, right? Like, it's like if you move your couch and it turns into like a TV, right? You should be freaked out a little bit. You should go, that's weird. You shouldn't be like, oh, well, that crap happens, right? Well, 180 over pi, if it means 1, pi over 180 should equal 1. Now, look at these questions here, how some are in degrees, some are in radians. Now, memorization, lowest form of learning, okay? There is nothing lower than that. Well, not learning is just, that's it, and then memorization. So, pi over 180 or 180 over pi, you're going to have to know those two, but what if I screw them up? What if I just go down to memory, that's it? Oh crap, was it pi's to radians or radians to pi's? Which one do I do? Okay, now this one's obviously in degrees, correct? So I will want it to radians. You're going to be looking, there will be a pi sign in the answer. Okay, there should not be a pi sign in the answer if you're going to degrees. Has there ever been a pi in your degrees before? So don't now go, yeah, I'm cool with it now though. Okay? There's never allowed to be a pi in your degree answer. So this one, I am changing to radians, correct? So I'm going to multiply by pi over 180. This is what we did last one, right? So what's 30 over 180? Math enter, enter. So that's pi over 6 or pi over 6 radians, right? Yes, you could. Now, B. B, is it in degrees or radians? What is the giveaway? No, not always.
The lack of degree.
Good. The nothing. Because if I said or if I just put 60 like that, what does that mean? It means radians. Okay? Now, do I want pi? Now I'm going to get to something degrees, correct? Do I want pi in there? So what if I multiply by 180 over pi? Do you see how the pi's will cancel? That is my giveaway that I'm, like, if I did it this way, because I forgot, it's test time, I'm like, everything's messed up, okay? And I put this, because like, I don't know, it's 50-50 chance. What's pi times pi? What's pi times pi? It's pi squared. Pi squared in your answer should be weird, okay? So, why am I telling you that? I want you to know it. I want you to go, ah, I definitely know it should be 180 over pi because I'm going to degrees and the pi should cancel. So you're going to go 2 times 180. Now, if you put it without brackets, you will get it wrong. You need to go 2 times 180 divided by 3. And that's 120 degrees. Okay, so what did I do? I went 2 times 180 divided by, or I'm going to split the division sign, slash 3. Okay, so do you see how multiplying by pi over 180 would be weird there? I would get a pi squared up top. If you're following the rules correctly of what you did. I guess I should put a degree sign there. Okay, 210. What would I multiply this by? Pi over 180 or 180 over pi?
Pi over 180.
pi over 180. Now here's another thing. See how there's a degrees here on the bottom? See how degrees on the bottom cancel with degrees on the top? Okay, that's another thing that will help you know you didn't flip it wrong. Or else you're flipping a coin to figure it out. Right? Like, nothing sucks more than doing 8 questions wrong because of that one basic thing that's mixed up with you. Right? Okay, so we got 210. Now, do you see how the pi will be left there? Which is kind of good for radians, right? 7 pi over 6. Now, put 7 pi over 6 in your calculator like this. Go 7 times pi in brackets divided by 6. What do you get? Right. You will get 3.7 radians, right? So, obviously this is exact. This is approximate. But you got to make sure you go 7 times pi in brackets divided by 6. If they want approximate, don't mess up the question there when you've already done the good stuff, which we got your 7 pi, right? So make sure, or else it'll just take the pi and divide by 6. Now, sometimes it works out, sometimes it doesn't, but whenever you have more than 2 things, always put brackets, right? And you're going to get it right. Okay? 9 pi over 5. What should we multiply by? 180 over pi. And all of a sudden the pi's cancel. And do you see how I have a degree sign there? Can it cancel with anything? No, that's why I'm going to be left with degrees, won't I? It didn't go away. You guys have done enough unit cancellation in Science 10, in Physics 20, right? So what do we get? 9 times 180, put that in brackets, divided by 5, 324 degrees. Okay, I'm giving you E and F right now. I want you to do them quick, and then I'm going to ask a couple people to help me. Okay, those 2 questions. Okay, pi over 2, what should I multiply by? 180 divided by 2? Does that make sense? The pi over 2 is 90 degrees. So it did when we were over here, right? There it is. 180, or sorry, 90 pi over 2. Right? So do you have to memorize this? No. Okay. But it's sure good to go, oh yeah, that's right. That makes sense. Right? I'll tell you, if you have to leave it totally down to memorization, that's when you can have a crappy test. Okay? When you're like, yeah, I had all my one rule wrong, and it just hurt me on everything. Okay, this one here, what are we going to multiply by? 180 over pi again, because I am going to degrees. Those cancel. Make sure you go 3 times 180 in brackets. Then divide by 2, and what do you get? 270 degrees, right? And that, again, was on my unit circle. Okay, so page 197 to 199. Again, don't take a 5-minute break. Get it done in class. Okay, everybody will get done in class today. If we go, we might even have time to get our test back. We'll see.